Here is the solution to the two-envelope paradox. It involves risk management. In order to be able to understand this solution, I'm going to go over a large number of examples involving risk, building this foundational understanding so you can appreciate the solution to the two-envelope paradox. So we're going to start simple. An imaginary stock valued at $100. One day it goes up 50%, the next day it goes down 40%. What's the value now? Well, if it's at 100, goes up 50%, now it's at $150. Now it goes down 40%. We have to take 40% of 150. That's $60. So it goes down $60. The new value is $90. What about the other way? 40%, then up 50%. If it goes down 40%, you're now at $60. 50% of $60 is $30. So the increase gets you back up to $90. So you lose $10 either way. How about the average? The average percent increase is you have to add plus 50 and minus 40, and that is plus 10 divided by 2. That's plus 5%. So on the average, it went up 5%, but your stock lost 10% of its value. So the average is clearly not good for determining the value of a stock. You have to use a different metric. You have to get the growth factor. So if a stock goes up 50%, what do we multiply its own value by? We multiply it by 1.5. If it goes down 40%, what factor do we multiply to get its new value? This is a little bit more challenging, but if it goes down 40%, you have 60% left. So you multiply by 0.6. So if a stock value is $100, goes down 40%, you multiply 100 times 0.6, and that gets you the new value of $60. These are the growth factors. The factors that you have to multiply the starting bankroll by to get the new bankroll. Up 50, down 40 is 1.5 times 0.9. Of course, down 40, up 50 is 0.6 times 1.5, which is also 0.9. So what can you calculate from the fact that the average percent change is plus 5%? And the answer is not much. Now let's consider a week of two stocks to really try to hammer this point home. Stock 1 goes up 80, up 80, up 80, down 60, down 60. If you add up those percentages, you get plus 120. Dividing by 5 gives you plus 24%. Stock 1 goes up 24% each day on the average for 5 days. Stock 2 also goes up 24% on the average each day for 5 days. They have the same average. If you get the value of stock 1, if it goes up 80%, you multiply by 1.8. If it goes down 60%, you multiply by 0.4. So stock 1 has a value of 0.933 of its starting value. You lost money. It's less than 1. You have 93.3% of what you started with. Stock 2, of course, is much better. You nearly tripled your money. If you invested $1,000 in stock 1, you would have lost $67, even though on the average it went up 24% every day. If you start off with $1,000 of stock 2, you would have made $1,929. Both have the same average percent change. There's no tricks here. It's just math. We're just multiplying things. We're doing it right. The arithmetic mean is useless when determining the final value of a stock, because the final value of the stock is determined by multiplying, not adding. To get the arithmetic mean, you add the percent changes, and that's not how to get the final value. If you want the representative growth factor, you need the geometric mean. The geometric mean is the square root of their product. So if a stock goes up 50, down 40, the representative growth factor for this investment each day is the square root of 1.5 times 0.6, which is the square root of 0.9, which is 0.9487. So if your stock is going to either go up 40, up 50, or down 40, the representative growth factor is 0.9487, which is less than 1. After 2 days, you square it. After 3 days, you cube it. Now, the second example we considered, with the 1 week of stock value. Stock 1 goes up 80, up 80, up 80, down 60, down 60. If we get the geometric mean of those 5 changes, we have 3 1.8s, 2 0.6s. We take the fifth root of that, and we get the fifth root of 0.93312, which is the final bankroll. So the representative growth factor each day is 0.9863, which is down 1.37% each day. Not good. So a stock that goes down 1.3% each day for 5 days is going to have the same final value as if the changes were plus 80, plus 80, plus 80, minus 60, and minus 60. Now, if you look at stock 2, the geometric mean is, of course, 1.24. 1.2, the fifth root of 1.24 to the fifth is 1.24. So if it does the same thing, the geometric mean is the same as the arithmetic mean. So raising the growth factor to the fifth power gives you the final bankroll. So the point here is that the average daily growth is not a good predictor. The geometric mean must be used. So now let's consider some investments. And these are model investments. Your rich, eccentric aunt passes away. Her estate says, look, here's what you can do. You can bring $1, and my estate is going to give you 2-to-1 odds on a coin flip. You can play as many times as you want, but you have to let it ride. You can't profit take. You have to put it all in or quit. So you win the first flip. You got lucky. You put in $1. Her estate put in $2. And you now have $3. Are you going to put that in? It's a good deal. You get 2-to-1 odds. You put in the $3. Her estate put in $6. You got $9 now. Are you going to put that in? If you put in 9, her estate's putting in 18. Seems like a good deal. If you lose any time, you got nothing because you went all in. If you do win 3 times in a row, you got 27. You're going to risk that? Her estate's putting in 54. It's 50-50. On the average, you're making $13.50. You win again. You got 81 now, 27 plus 54. You let it ride again, you got 243. Again, you're on a hot streak, 729. You win again, 2,187. 6,561. Are you starting to sweat? 10 straight wins, $19,683. 11 straight wins, $59,000. That'll get you a nice car. 12 straight wins will get you a house. If you put that in, her estate's putting in more than $250,000. This seems like a good deal. If you accept this proposition, on the average, you're making $88,000. $88,500 if you play one more time. Every coin flip is a good deal. You can calculate it. If your only criterion for an investment is that it has a positive expectation, you're going to go broke because every coin flip has a positive expectation. It seems like there should be some point where you stop. And there is. And we can calculate it, or at least estimate it. So here's one more model investment. The same rich eccentric aunt, but this time, instead of asking you to bring $1, she gives you $1 million. Here's your $1 million. You now have $1 million. And if you want, you can risk any fraction, including 0, on that one flip of a coin. Only one. You don't get more than one flip. She's giving you 2-to-1 odds. So if you put in 100,000, her estate's putting in 200,000. 2-to-1. If you win, you'll have 1.2 million. If you lose, you risk 100,000. You're going to have 900,000. How much do you risk? Invest some time thinking about this. This is an important question. Some people will risk a large fraction. Some people will risk a small fraction. Some people don't risk anything. Some people risk it all. Is there a proper amount to risk? Or is it just depends on your personality? Is it better to be conservative? Is it better to be a risk taker? What we're going to do is we're going to answer the question with mathematics. We're going to assign a variable called capital F, and that's the fraction of the bankroll that we're risking on an investment. If you decided to risk 100,000, your F is 0.1, 1/10 of the 1 million. If you risked 250,000, your F is 0.25, 1/4 of your $1 million. If you risked it all, your F is 1. And if you don't play, your F is 0. I'm keeping my 1 million, I'm walking away. So if you risk F and win, what is an expression for your new bankroll? Do this. Risk F and win. What is the expression for your new bankroll as a function of F? Well, you get double your money. So your profit is 2F, but you also have your initial bankroll, so you multiply 1 million by 1.2F, and you can plug in numbers and see that it's correct. So if you plug in 0.1 for F, that's $100,000. So F is 0.1. 2 times 0.1 is 0.2. 1 plus 0.2 is 1.2. And when you multiply 1 million by 1.2, you get 1.2 million. If you risk F and lose, what is your new bankroll? Well, if you risk F and lose, you only lose F. And you're losing it, so you have to subtract it. So it's 1 minus F times 1 million. And in our example, if F is 0.1, 1 minus 0.1 is 0.9. 0.9 times 1 million is $900,000. So both equations work. The average of the new bankroll, well, to get the average of two things, we add them up and divide by 2. If we add those up, divide by 2, do the math, we get 1 million times the quantity 1 plus F over 2. What does this look like as a function of F? If I plot my average bankroll versus F, what does that look like? 1 million times 1 plus F over 2 versus F. And if you know anything about algebra, that's a linear function. It's a straight line. There is no peak. There it is. This point is not betting. The other point is risking it all. And if you risk it all, if you put in your 1 million, she's putting in 2 million. Right? You're getting 2 to 1. So you're either going to have 0 if you lose or 3 million if you win. So the average of those two is 1.5 million. And that's what that point represents. So if you have a positive expectation, and that's your only criterion, you're going to risk it all. If you want the highest bankroll on the average, you should put in the whole 1 million. But we have seen average outcome is not a good way to determine whether an investment is favorable or not. You have to use the geometric mean, and we can calculate the geometric mean. Here's the two growth factors. 1 plus 2F if you win, 1 minus F if you lose. Instead of adding them up and dividing by 2, we have to multiply them and take the square root. There it is. Now what this function looks like is not obvious. If we plot the growth factor versus F, we can plug in some numbers for F. We can plug in 0.1, calculate the growth factor, plug in 0.2, plug in 0.3, and eventually get a plot. And it's very interesting. It tells a very different story than the arithmetic mean. And this is the real story. So here's the representative growth factor versus F. It has a peak. The peak is at 0.25, right there. So the math tells you you should risk 1/4. If you risk 1/4, you'll either have $750,000 if you lose, or 1.5 million if you win. And there's a lot of assumptions going on here. I'm not saying that 25% is right. I'm just saying if you don't make any other assumptions and you only consider the growth factor, you get 0.25. That's where the peak is.